good morning from out here at Stanford to Luigi Ferrucci and the conference participants where he's going to be moderating. We're very privileged to have Luigi. He's the scientific director of the esteemed National Institute of Aging, one of the institutes of the National Institutes of Health. He's been the scientific director for the past 10 years. He has been the director of the Baltimore Longitudinal Study on Aging for about 20 years. So Luigi is a distinguished epidemiologist and geriatrician, and I turn the meeting over to you. Thank you. Good morning.
Excited to be starting this conference, and I'm particularly excited at the fact that we start with the word geroscience. I think that geroscience is infusing new life to the research on human health and is at the front edge of a transformation of medicine that will focus more on global risk factor for disease rather than specific disease themselves. And really is spurred from the idea that aging, it's really the driver of change that occur over the lifespan. I want to just give you 2 minutes of introduction because I have speakers that are outstanding: Matt Kaeberlein, Brian Kennedy, and Gordon Lithgow that can, take you to the geroscience, better than I can ever do. But what I want to say is that, we have been concentrated on the aging process in this part of life. That is the part of life of the decline. When disease and disability impact on our ability to fully enjoy all the possibilities of life. It's becoming very clear that many of the change at the biological level that actually, in fact, the good or bad trajectory of life later on occur much earlier. At the time when we don't see many change, we don't see the emergence of disease, but because the compensatory mechanisms that have been evolutionarily selected are so powerful that hide and cope with these changes. And in order for us really to understand what's happening later on, we will need to concentrate on the entire lifespan. And also, I want to tell you one more thing, that it's, let me see if I can change my slide here, give you the next slide. Well, I don't seem to be able to do so. So I'm just going to tell you by words. The issues that what we are finding out is that there are many, many different metrics of aging. The three most important are the functional metrics, where we need to study how people change in their ability to be functionally in the environment and to maintain their cognitive status. In order to understand and affect them, what we need to do is to understand what is underneath this change in terms of phenotypic change and in terms of molecular change. And because of the strategies that I was talking to you about, there is a time gap between these events. The molecular change occur much earlier in life and affect the functional change that occur later in life. So we need to really look at longitudinal perspective if we want to really address them, understand them, and use them as target to improve life in old age. Having said that, I want to leave the time to my colleagues that will be working and talking about. As I say, I want to introduce Matt Kaeberlein, Director of Healthy Aging and Longevity Research of the Institute on the University of Washington, USA. Matt, are you here?
I am here. Good to see you. Hopefully this is working. All right, so I guess I'm sharing my screen. No? Oh, great. Okay, so hopefully you can all see the slide here. So first of all, I want to thank the Metabesity organizers for inviting me back this year. And I have to admit, this talk came out a bit differently than I thought it would when I started thinking about it. So I was asked to present in the panel on milestones in geroscience. And when I started really thinking about some of the key milestones in this field, you know, I think there's been fantastic advances on the basic science side, but what I see as really the major milestone is one that hasn't happened yet, and that is when the field will achieve, I think, the recognition and respect that it deserves. And next slide, please. Am I advancing, or is somebody advancing for me? Thank you. Which is to get the respect that that I think the field deserves. And I think, you know, when you look at the field of geroscience among the broader biomedical community, I think many people in the field recognize that it probably doesn't receive the respect that it deserves. Next slide, please. And I think there are lots of indications for this, but if we just look at the funding of geroscience compared to its importance. So I think we all recognize that the biology of aging is the greatest risk factor for nearly every major cause of disability and death in developed countries. And yet when you look at the federal funding for biology of aging, it's less than 1% of the NIH budget. And even at NIA, it's less than a quarter of the research funding goes to the biology of aging. And I think there are lots of reasons why the field maybe has somewhat of a reputation problem among the broader biomedical community, among policymakers. I think for a long time, there has been a perceived lack of rigor in the field. I don't agree with that, but I think it is a perception. Historically, perhaps it stems from 20, 30 years ago when much of the work in the field was descriptive while other areas were becoming mechanistic. But I think this still persists to this day among people who don't work on the biology of aging or really understand a lot of the research that's happening. Associated with that is there has been for a long time what many of us refer to as a fringe element, which appeals to the media and talks about living forever or uses words like curing aging, which I think, again, when you look at serious people outside the field, they hear that kind of language and it does not resonate. In fact, again, it contributes to a perceived lack of rigor. And then more recently, we've seen a trend where scientists in the field, you know, have in some ways moved away from the clinical trials and started promoting supplements and writing books. And while I'm not making any moral judgments about that, I think we have to be aware that this does have an impact on the way the field is viewed. And then I would also argue that there has been a shift towards a focus on biomarkers rather than functional endpoints. And Luigi mentioned functional endpoints, and I feel like we really need to continue to focus on functional endpoints so we can really evaluate whether some of these interventions that are being developed are actually having the effect that we hope they're having. So I'll just say, I think, you know, the game changer here in many ways will be the first successful, well-designed clinical trial in geroscience. But that's hard, and I think it's clear from some recent failures how hard that is. I'm not going to talk about it today, but I will just mention that I think companion animals and companion dogs in particular may offer a path forward where you can actually do clinical trials for lifespan and to some extent health span in a reasonable time frame. And then what I want to spend the rest of the time talking about is how COVID-19, which we're all dealing with, you know, presents both challenges and possibly opportunities in this area to really emphasize the value of a geroscience approach to human health. Next slide, please. On my computer, the animation isn't showing up. Hopefully it is for everybody else. But if it's not, what you would see here is that when we look at the risk of severe complication or death from COVID-19, it looks very much like any other age-related disease. Your risk of developing a severe outcome once infected with COVID-19 or dying from COVID-19 shows essentially the same kinetics as a function of age as Alzheimer's disease, most forms of cancer, heart disease, diabetes. So I think it's clear that COVID-19 is very much a disease of aging. And certainly this was recognized early on when the most severe outcomes were seen in a nursing home in Kirkland, Washington, not too far from where I live. Next slide, please. And so why is that? And again, I think those of us in the field of geroscience recognized early on, it's because the biology of aging is what's driving the risk for severe outcomes from COVID-19. The biology of aging is why elderly people are frail and less resilient. It's why they have more comorbidities. And it's why they have a weaker immune system. And so the underlying biological processes that go along with aging are really what's driving this greatly enhanced risk of severe outcomes and death in the elderly. Next slide, please. We also know that there are medicines that seem to slow the biological aging process. And I think three of the best candidates are shown here: rapamycin, metformin, senolytics. There are certainly others. But the point here is that these things exist. There's absolutely rock solid evidence in preclinical models that these things target the biology of aging, seem to slow or in some cases reverse functional declines that go along with aging. And in each of these cases, there's some evidence, either preclinically or clinically, that these medicines could be effective in the context of reducing the severity of outcomes in people who are infected with COVID-19. And in the case of rapamycin in particular, we know in mice that it can rejuvenate the aged immune system, enhance response to a flu vaccine, and then there have been 2 successful phase 2 clinical trials in healthy older people suggesting that a derivative of rapamycin can boost immune response, boost vaccine response, and reduce infections from a wide variety of infectious agents over the subsequent several months. So there's good evidence that these molecules may actually be effective at reducing the severity of outcome from COVID-19 and other infectious diseases. Next slide, please. And yet, when we look at the research funding for COVID-19, I think there's no other word for it but a disaster. So if the animation was working, this dog would look perplexed, as if he was trying to understand how could it be that of the more than $4 billion set aside for COVID-19 research, zero was allocated to aging or NIA, despite the fact that aging is the single greatest risk factor of severe outcome or death once infected with COVID-19. And I think this goes back to what I started with, which is that the field to some extent has a reputation problem, and the importance of the field is not widely appreciated among the broader biomedical community. I think this is evidence for that. Next slide, please. So where did most of that money go? A lot of it has gone towards a vaccine, which is important, and I absolutely think we do need a COVID vaccine. But I also think it's important to appreciate that we've had flu vaccines for a long time, and we still have hundreds of thousands of flu deaths every year. So vaccines will help, but they're going to be least effective in the most vulnerable individuals, the elderly, and they may not provide broad protection. So a vaccine for COVID is not going to be a cure-all for the problems that we're facing. Next slide, please. And so I'll just sum up by comparing this to a geroscience approach. So if we had a drug like rapamycin or like one of these other interventions that seems to really target the biology of aging, it certainly could be effective at enhancing a COVID-19 vaccine response. But unlike a COVID vaccine, it's also likely to protect against other viruses, other non-viral infections, and other aging diseases. And so I think to some extent with this audience, I may be preaching to the choir, but I think there's a lot of reason to believe that a geroscience approach to COVID-19 has the potential to really be a game changer. Next slide, please. And so this is the last slide, and I just want to mention what I see as maybe what we need for geroscience to take center stage. As I've sort of indicated, I think COVID-19 is both a challenge and a potential opportunity. But in order for geroscience to really reach its potential, I think we need leadership. I think it's clear that at the highest levels of government and policy, we don't have people advocating for geroscience. I think we need to do a better job of educating policymakers and the general public, and I think this meeting is a great way to contribute to that. And I think we need execution. We need really well-designed clinical trials with endpoints where there's a high probability of success. And next slide, please. With that, I will stop, and I'll be happy to take questions either now or during the discussion. I'm not sure how we're doing that. So thank you.
I think it would be nice, to keep going and have the presenters and maybe address questions later on, unless, Brian and Gordon have something they want to say after, Matt's presentation, which was really provocative. I would say that I'm more optimistic than you are, Matt, because I think that the geroscience is a really young field that is progress credible and permeating, the big shot of medicine very, very quickly. I'm actually amazed how this is appearing in the LAR conference on cardiovascular disease, on cancer, how much is really creating interest in the entire medical community. And I see that, we're still in a phase where we don't have the respect we really deserve, but I think it's happening. I'm very, very positive about that. I don't know, Brian, do you want to say something and, intervene, make your presentation, or have, interaction with what Matt said?
I think, was Gordon going before me? I would just like to add that I disagree with everything Matt said, as usual.
That's good. That's where the discussion is going to come. So, okay, Gordon.
Yeah, good morning. First of all, what a pleasure it is to take part in this amazing conference. What a lineup. It's really superb. And it's great to see you, Brian and Matt and Luigi. Well, I had a few comments. I mean, first of all, I really appreciate a lot of what Matt said. And I do feel that the field is at an inflection point where there is the opportunity to move from being essentially a science project. The last 20, 30 years, we've all enjoyed this field. We've all enjoyed discovering the mysteries of aging and extending lifespan of simple laboratory animals, and it's been enormous fun. But the implications from what we're seeing in the laboratory are that we can actually do something for human health. And it's quite sobering to realize that we could be at a point where we're going to really change biomedicine. To do that, we need various approaches. We're going to hear about lots of them at this conference. One approach I just want to mention is this idea that Matt already mentioned, is the small molecules that extend lifespan, that essentially are drugs for aging. And since aging, we believe, is the common cause of multiple disease pathologies, then targeting aging itself is likely to lead to preventions or cures for many of the diseases that we are faced with in late life, including Alzheimer's, cancer, and so on. That's the geroscience approach, that we have this common cause of multiple pathologies, and targeting that cause could be quite dramatic in terms of human health. So how do we do that? Well, we mentioned rapamycin and metformin, and unfortunately, we've been talking about these compounds for many, many years now, and the deck is actually quite small when it comes to compounds that we believe are potentials for humans. And so we need to find more compounds. We need to find hundreds of rapamycins and hundreds of metformins. And this is difficult to do because targeting aging means studying lifespan. And if you study lifespan in a mouse, for example, it's 2 or 3 years and incredibly expensive. We know we can't do it in humans unless we're looking at surrogate biomarkers, and we're obviously going to talk a lot about that as well. But one of the ways that we've done it to date is to go back to the simple laboratory animals that we've been studying aging in for 30 years. And this is things like yeast, as Matt and Brian, as pioneers in this field, showed that this is a model for aging that can be significant for human health. And the simple nematode worm, C. elegans, is a place where we've screened tens of thousands of compounds for the effect on lifespan itself. And that's really important, that you actually screen on aging. That's the phenotype, that's the thing you actually screen on. And so many molecules have come through from actually studying these organisms. And I want to mention one this morning that Brian and I have been working on. And this is a metabolite, a natural metabolite called alpha-ketoglutarate. And this was first published by the Hung lab in Nature as extending lifespan in the worm. And it was a compound that kept coming out of our chemical screens for lifespan extension in C. elegans, the nematode worm. This is a worm that if it's unfamiliar to you, this is a tiny animal. It's a millimeter in size. It has about 1,000 cells and lives for about 20 days. And that's a critical factor, 20 days. It means you can actually uncover molecules that extend lifespan within the period of a month. And we thought this molecule was doing really well in these simple animals, and Brian and I thought that this might be something that we could take into mouse. And we should talk about models and you know, human cell lines and organoids and different models where we can test the effects of compounds for aging pathologies before we get to that point where we're undertaking the clinical trials that Matt so rightly pointed out are absolutely necessary. And that's where we're going to see the wins in this field is through a well-designed clinical trial. So to have scores of molecules set up to do that, we really need to go through different animal models, and the mouse remains a major model. And recently we just published a paper in Cell Metabolism where we show that alpha-ketoglutarate not only extends lifespan in simple worms, but actually extends lifespan in the mouse as well. Now this has been done many times before from different labs with different compounds. But in this case, we brought an instrument to bear on the issue that I think's important, and that is to look at various functional measures of aging that are associated with measures that Luigi would make in his human cohorts. So this was a Frailty Index, which is a series of observations on aging. It's not a deep dive into the function of aging in the mouse, although we can do that as well. As I say, it's mainly observational, but these measures were the kind of things that you would look at if you were looking at a human population. And what we found with a composite score established from these observations was really very exciting, really exciting. Actually, I'm going to turn it over to Brian, who's the mouse expert here, and just to describe what we saw when we measured this frailty index in the mouse fed with alpha-ketoglutarate.
Yeah, thanks, Gordon. You know, if Rich Miller heard me being called a mouse expert, he would probably go crazy, but I'll try. And so I think that what is exciting about alpha-ketoglutarate, and I'm going to go on to a couple other issues, but I'll just mention this, is that it compresses morbidity. So it has a bigger effect on health span parameters than it does on survival. And so for us, that's very exciting, because if it were to have a similar effect in humans, it would be a huge win, both for quality of life and for reducing the healthcare costs associated with aging. And so there's 2 points I want to make about small molecules, and maybe I'll use alpha-ketoglutarate as an example of that. The first is that, you know, I think that it's great to have small molecules that have an impact on aging in animal models, but it's also critical to know mechanistically what they're doing. And so one of the things we're really working hard on in my lab is to understand the mechanism by which alpha-ketoglutarate is affecting aging. And this is a bit of a challenge because it's a little bit like NAD in that it participates in about 1,000 different reactions in the cell. And so if you want to tease out the ones that are relevant for aging, you've got a bit of a challenge on your hands. What excited or got us interested in this particular mechanism I'm going to tell you about is that AKG has been used by exercise people for a long time to enhance endurance and also for resistance training. And so we started thinking about why that might be. There was the other clue that we had was that AKG doesn't easily get taken up by cells. And so so most cell types don't take it up. So there was a paper in 1963, which was before I was born, almost, or just barely before I was born, that showed that AKG is readily taken up by red blood cells. And the reason red blood cells like AKG so much is they have to make a lot of glutathione. which is not easy to make in a red blood cell, which doesn't have a functional mitochondria. And so they have to have alternate mechanisms to do that. And so AKG produces a large percentage of the glutamine that goes into glutathione in red blood cells. And we can now show in the animals, in old animals, that we can increase glutathione in red blood cells fairly dramatically by adding AKG. So what this we think is doing, I can't believe I'm supporting an antioxidant mechanism here, Gordon. I hope this is not being recorded because it's, I've always been a little bit skeptical of antioxidant mechanisms, but in this case, it could be incredibly relevant because red blood cells are carrying a lot of oxygen around. They're very susceptible to oxidative damage. It alters hemoglobin function, it alters the shape of red blood cells, and we think it alters oxygen carrying capacity of red blood cells. And we can show that we can improve those parameters now with AKG. So this is a very simple mechanism. It could explain exercise endurance phenotype, and it may explain some of the aging phenotype. So we're excited about that right now. But I think that the last couple of minutes, I just want to talk about the clinical stuff because I came to Singapore because we really want to go into clinical studies to try to show impacts on aging. And so AKG is a supplement. So I'm actually probably more supportive of the supplement industry than some, except that I believe we need to inject real data and do meaningful science behind this and not just purport that things work. And so we're trying to think hard about how we validate whether small molecules like AKG or even drugs have impacts on aging. I'm probably a little bit more positive about biomarkers than Matt. I think they are going to be very good endpoints, but they have to be combined with functional parameters as well. And so we're trying to design studies that combine those two elements. So we're looking at things like a 6-month to 9-month study with individual components like AKG in people that are late middle age, maybe 50 to 65, that are not yet with chronic diseases. And then to try to see which biomarkers can be impacted by specific interventions, which functional parameters. We're particularly looking at inflammation with AKG, for instance. But there may be other things with other small molecules that are more important. And I kind of see the interventions as keys, the biomarkers and the functional readout as locks, and then you have to figure out what keys fit in which locks. And when you open those doors, what are the physiologic benefits you can find? So our goal is not to do something like the TAME study, which I think is a great idea, but it's a huge study that costs a lot of money. We're trying to look at multiple different kinds of interventions side by side and see which ones have the biggest impacts on those markers. So I don't know if 6 months is long enough. It's hard to calculate power because these studies have largely not yet been done. But we're very excited to sort of jump into maybe the deep end of the pool, and hopefully we'll get some outcomes that begin to show that these interventions have an impact on aging. Because I agree with Matt that however we do it, we have to start generating human data that some of these interventions are going to have impacts. And I don't know which interventions are going to work the best. I think we all have our favorites. And I'm not sure what the best clinical strategy is. So I feel like we have to explore different avenues and start to generate data, and ultimately we'll figure out what works best. So I'll stop there, and maybe we can go on to discussion. Luigi, you're muted.
Oh, sorry. I think the discussion is really going in the right direction. And, I will agree fully with what Matt said that, the field needs to acquire more rigor and more credibility. I mean, we need to play with the big guys, because I think that would be important also kind to forward our ideas. But I would say, I have a provocative, question for all of you. In 1958, Nathan Schock decided to, create the BLSA, the Baltimore Longitudinal Study of Aging, because he wanted to distinguish aging from disease. And he wanted to say, so we can take out aging and really understand what diseases are. And I think that over time, we have discovered that was the wrong question. Because when we start improving our technology, we found that it's not really a clear-cut, distinction between aging and disease. And I think that that make the study of aging from almost a philosophical statement to, as I said before, the front page of medicine. We can't really do progress in medicine if we don't understand aging. How do we best interface ourselves with the official medical field? How do we convince them that the geroscience approach is really important and need to be part of the big game? Matt, do you want to try to address that?
So sure. First of all, I don't think it's easy, right? I mean, I think that there are some real challenges with communicating with clinicians about the importance of biological aging. So I think there's conceptually, to my mind, the biggest challenge is that traditionally medicine has approached health from the perspective of disease, as you were just alluding to. Typically, we wait until somebody is sick, we diagnose their disease, and then we try to treat that disease. And this pervades every aspect of, I think, the way that clinicians tend to view human health. And from the regulatory perspective in particular, I think this is a real challenge because FDA and other regulatory bodies are used to clinical trials that try to improve health in somebody who's sick. I think from my perspective, again, we need to get away from thinking about healthy elderly people as opposed to elderly people of normal health status. And what I mean by that is that an elderly person of normal health status functionally is not the same as a young person. And when you think about health from that perspective, then it becomes much easier to imagine interventions that improve function in an older person of normal health status. So I'm not really answering your question because I don't have the answers, but I think changing the mindset is going to be key. So there's the science, right? Continuing to do rigorous mechanistic studies. I completely agree with what Brian said. This is going to be easier for people who don't think about aging this way to accept if we have mechanism. So that's critically important. But I also think trying to change the way that clinicians view health is going to be maybe equally important to that.
Can I jump in and say that, you know, the one group of clinicians that we can really interface with are the geriatricians. And my colleague, John Newman at the Buck is frequently telling us that geriatricians think in the same way that geroscientists do, in the sense that it's highly interdisciplinary. They're not looking at one condition or one mechanism. They're looking at the very holistic view of people. And I think the geriatricians can get the geroscience perspective. And of course, they're the people that in the end are going to potentially be delivering the interventions or the therapeutics that we're going to develop. So we should really push hard to develop the relationship between geroscience and geriatric medicine.
Yeah, this is Brian. I would agree with that, and I think John's great. But I think that it's worth pointing out that the geriatricians are really managing aging, you know. And I think what we're trying to do to a large extent is prevent aspects of aging, intervene earlier. And so I find that a lot of geriatricians are not thinking the way that we're thinking, and that we're finding that people in like the cardiovascular space and the metabolic space, endocrinologists, like Nir, that are thinking about how to take markers of disease or risk factors like cholesterol, for instance, and treat those factors prior to disease onset. And I think that mindset actually aligns better with how I think about targeting aging. And so we're certainly trying to reach out to geriatricians, but here at NUS, we're interacting with a range of different clinical departments, because, and particularly people that are looking at early stage interventions to prevent disease.
I think this sequela is really, really important. You know, the education, training, and mentoring, you know, of what the geriatricians are, has really generated this generation of geriatricians. But I really think that we need another generation of geriatricians that think about geroscience in a different way, where, you know, studying aging start maybe a conception and not even a birth, where if you really want to affect the long-term outcome, you need to act early and understand mechanism. And maybe, the most effective intervention you can implement are those that are early in life, when, you create the epigenome that people will follow, will bring with them late in life. And so I think that permeates the entire lifespan. It's an important concept. We need to go to the geriatric school and specialties and give class and, kind of create an osmotic movement of science in that direction so that can be translated into clinical practice.
Yeah, I agree with that. And I think that, one thing, I think John is an example of that kind of new breed of geriatrician. And I also think that people at Mayo Clinic with Jim Kirkland, they're really trying to train new geriatricians with an eye toward geroscience. And so I think we need more infusion of that kind of concept into training programs in the geriatric space. And I think that'd be very important.
Yeah, I agree as well. And I think this is starting to happen slowly, but I'll also come back to one of the points that I tried to make in my talk, which I think if we have a success in the clinical trial realm, that will go a long ways towards changing mindsets as well, right? I think the first FDA approved intervention in geroscience will have a big impact in changing the way that people think.
I have a comment on that. Certainly TAME is an incredible, enterprise that has been very important. It's also teaching people is kind of how difficult it is. But other people think that another possible approach will be to use the approach of geroscience to try to address common disease, treat osteoarthritis with the senolytics, for example. And that, because it's more acceptable to, the regulatory community, will be a sneaky way of getting geroscience into medicine. I wonder what you think about this kind of approach.
Maybe I can take a first shot at that. It's a sneaky way, but it's also kind of a sleight of hand, because I see, again, I see this more as a preventative approach targeting a risk factor. Once you have overt disease, that doesn't, targeting those early stage risk factors may or may not have much outcome. And so while I totally get the FDA approach and that has to, for approval, and the reimbursement concepts associated with trying to treat disease with longevity molecules, I'm not sure it's going to work very well. I mean, we haven't had a lot of successes so far, and maybe that's just bad luck, but I really think we need to, if we're going to target aging, we need to measure aging. And I think not enough of that's being done. I think if you look at NEAR's trial, they're looking at aging biomarkers as well, so that's good. But I'm not so sure that finding something that hits an aging pathway and then trying to pick which disease you're going to treat is going to be that successful at the end of the day. At least so far, it hasn't been that successful. And so I feel like we should be measuring the thing we're trying to impact.
Yeah, so I'll just add on to that. I mean, I think Brian's absolutely right. That is my biggest concern as well, that at some point the pathology of the disease may no longer be the same as the mechanisms that are driving biological aging, in which case the intervention may or may not work, even if it's targeting aging. So that's the concern. I'll also say, though, that I think, Brian's correct that there have been some failed clinical trials, but the number is really small. So I think we really don't know how effective that approach is going to be. And I would just add, again, I think that's where these functional measures of aging come into play. And in some organ systems, it's not completely clear, where you pass over that threshold of functional decline of aging to outright disease. And I actually really like the approach that, and I think Joan Manick is going to be talking later, conceptually, that Restore Bio had. We know that immune function declines during age, and that in principle, targeting the mechanisms of aging can be effective at restoring some aspect of immune function. So I think that kind of approach has promise, but even those clinical trials are extremely difficult, and it's not helped by the fact that so far, I think that it's very challenging to get FDA on board with the kinds of endpoints that those of us who think a lot about aging would like to see as endpoints for a clinical trial.
I think that Matt has a very important point, but think about what TAME has done in terms of the revolution of thinking in the FDA. I think that they started with a complete, absolutely not, this is not an approach. And then they started, joining a discussion and coming to a compromise. And I think that in a way, those are the trials that we will need to do in order to learn enough about how to do a clinical trial, on a health outcome in all the people that target the Geroscience approach. Without that, we're only talking in theory, and clinical trial has a lot of details that need to be ironed out before they can be launched. So I think that is still very, very valuable, approach.
Luigi, can I ask you a question? And that is, I think we're all supporters of TAME, but we're now sort of 4 or 5 years into this process, and I agree it's definitely changed hearts and minds, but we're still talking about metformin. And what do you see that needs to be done in order to have multiple TAME trials, to have 10, 20 TAME trials all lined up to happen? I mean, what do we need? What do you see in terms of the data that's required from animal models or from other systems in order for clinicians to get excited about an intervention?
So there is one thing that to me is key, is transport those measures on the mechanisms of aging from animal model to humans. So we are not there. We have very few of them, and those that we have are not high throughput, can done only in very small population. And unless we can show not only that the functional outcome is affected, but the mechanism that we are pretending to approach and to change are really changing in accordance with the functional outcome, I think would be very difficult to really convince the scientific community. And what Matt said at the beginning is also true. I mean, there is a leadership issue. We need to, have someone in the government in a way, someone that, is in the FDA, that start understanding how important is this field and, become our advisor and help us, developing a common language by which, we can find to a compromise, at least start testing these hypotheses about Geroscience. Again, I'm optimistic. I think it's happening in the different meetings. You feel that, the wall is crumbling and that the windows are opening. And so I think that slowly and progressively this will actually happen.
Yeah, and let me just clarify. I don't want to come across as if I'm pessimistic about Geroscience. I'm just frustrated at the pace, I would say, as I think many of us are. And so I think it's useful to push a little bit and see if we can get some movement. The other thing that I would add, so I think, you asked Gordon, what would it take to have a TAME trial for 10 or 12 different interventions? First of all, we need the interventions. And I think this is, what you were getting at in your talk. We have maybe 4 or 5 that are reasonable candidates, I think, to move to the scale of TAME at this point. We can argue about what they are, but it's not a huge number. The other thing we need is money, right? These clinical trials are hugely expensive, and there has to be a profit. Either there has to be federal funding or some non-for-profit funding come along, which hasn't happened yet, or it has to be a new investigational drug, right, where somebody can get a patent on it to make money off of it. And I just wanted to make one point, which is I feel like the field has been at least too rapid to move away from the molecules that we know about, rapamycin in particular, but metformin as well. These things, especially rapamycin, haven't been explored clinically for aging in people. There's a shiny object syndrome in the field where we've known about rapamycin for a long time. It's the most effective drug we have at slowing aging preclinically, for sure. Nobody can argue with that. And yet the field wants to move away from it. And I think there are concerns about side effects, which is another issue that you have to think about in a geroscience clinical trial. My personal feeling is that concern is overblown and not data-based, but it's real. But I think that there's a big part of the field that wants to not talk about mTOR and rapamycin anymore because we've known about it for a long time. And I just want to make the point, this really hasn't been explored in the clinical realm for aging indications. There's actually very little data yet. So we don't know, and I would say it's our best bet. If we had to pick one thing to move forward with, that's the one that's most likely to work in my view.
I actually, you may not be surprised to hear this, but I agree with that. I think that rapamycin is probably the gold standard in animal models, and we do have a tendency to run away into new directions, and there may be things that have a much bigger impact down the road, but I think if you look at the animal data, it's very compelling. I would just want to point out that, you know, Matt's a shy guy and he doesn't like to talk about his own work, so I want to talk about the dog aging project a little bit. You know, I think that this is a really important step forward because there is a study plan with rapamycin, but if any intervention works in this context, I think it's going to be a big bridging point to get into human studies in a much larger way, because predominantly because these are pets that live at home, so people are aware of what's happening if you see a positive outcome, but especially because they're living in the same environment as humans. And so one of the things clinicians say all the time is, great, you did it in mice, they live in a pathogen-free environment, it has nothing to do with what's going on with the aging in humans. And I think this dog study is very important, because if you get positive outcomes, it gets rid of that concern. And so I'm very hopeful that those studies proceed well with rapamycin or some other intervention.
Okay, we have the last 5 minutes, and you know, I'm missing those conferences where this discussion could be continued in front of a cup of coffee outside the conference room, and I hope we will get there very, very soon. But you know, each one of you has a word of wisdom of what should really happen. If you were to select one thing that we need to accomplish to advance the agenda of geroscience, what that thing would be? Short, you have 1 minute. Ryan.
Well, I guess we got 50 minutes into this thing before the word money came up, and it is money. There's no question about it. I think we need a massive injection of funding into this area at the federal level, but also an attitude towards commercialization and provide academic scientists with the tools to move toward commercialization, because that's also where the money is. And I'll leave it at that.
Okay, maybe I'll supersede Matt, because I'm going to say what he says, I think. So that means he has to come up with something else. And first of all, at a conference, you know, it may be early for you, but, you know, they say it's 5 o'clock somewhere. Well, it's well past 5 o'clock here. So I'm not having coffee, I'm having wine. The main point I want to make, though, is that I think we need successful studies in the clinic. And I don't even think it matters that much how they're designed, as long as they're well designed. And I'll just point out that there was this study in aging cell that came out late last year. And it was a study of 9 people doing self-administering 3 different interventions, and then measuring the effect of methylation clock. And we can all debate, you know, the lack of controls in the study, whether methylation clock is measuring aging. I just want to point out one thing, that we can look at downloads from aging cell, as I'm one of the editors in chief. And usually a paper that comes out for 6 to 8 months, you're lucky if you get 3,000 to 5,000 downloads. We had over 100,000 downloads of that paper suggesting you can reverse biologic aging. So again, without commenting on that particular set of interventions and how that study was designed, I think we need more studies like that with the biomarkers, and particularly if we can add functional parameters to that. There was a little bit done in that study, but not that much. If we can add those things, I think we're going to start to really change public attitudes, and that'll come back to Gordon's comment about getting more money into the field.
Okay, well, since Brian took my answer, I'm going to say that the thing that will have a huge impact on the field is if we're able to slow aging in people's pet dogs. I think if you want to get people excited about the biology of aging, you make their pets live longer.
Thank you very much, everybody. And I think that Thomas, I think
Yes,
our time is
Luigi,
up.
we actually, can you hear me, first of all? Sorry about
Yes,
that.
I can
Yes.
hear you now.
Excellent. So we have about 5 minutes for your panel, Luigi. There are over a dozen questions that have piled up. There are some that are upvoted, so maybe I'll just pass a few on to the panel for like quick 30-second, 1-minute answers. Felipe Sierra asked several questions. Hi, Matt. Thanks for the excellent talk. Can you update us on the current status of the Rapamycin branch of the dog aging project? You mentioned that you're doing it. Where are we on it?
Yeah, so I think, like almost everything else, this has been slowed a bit by COVID-19. So the infrastructure, so we've completed 2 trials, have evidence for improved heart function, no evidence for side effects, and we will be enrolling dogs into the 3-year, 500-dog, double-blind, placebo-controlled clinical trial to really answer the question, does rapamycin slow aging in dogs? Probably in February. So the infrastructure is built. And I think we'll have the first dogs in the clinic first quarter of next year.
When do you expect readout?
Yeah, so it's a 3-year trial. We will have interim analyses for side effects. I don't think we're going to have functional or lifespan data for, till the end of the trial. So it'll be a few years. I mean, these things take time.
Moving quickly to Brian, this is another question for Felipe. What markers are you using as endpoints? Molecular, cellular, functional? You're on mute, Brian.
The answer is yes. We're using several of the aging biomarkers that have been reported, methylation clock. There's biomarker from complete blood count data. There's biomarkers available that we're trying from even reconstruction of facial patterns that's been recently published by Jackie Hahn. We're combining that with inflammatory cytokine panels, metabolic markers, and then also things like pulse wave velocity and non-invasive things we can do to look at function in people. And so we're trying to, and part of that is to see how these different parameters interact with each other and not just to look at how interventions impact them. There's kind of 2 questions there.
This is a follow-on for you from Gordon Cutler. How will you select dose finding for the AKG short-term biomarker studies?
Yeah. Well, one of the reasons we chose AKG is because it's extremely safe. It's a GRAS molecule, generally regarded as safe, and it's been dosed up to 10 grams a day in clinical studies with no toxicity. And so we're not that worried about toxicity here, but I do think that the question is, at what dose should we try? And we're probably going to do a dose response initially before we start the real clinical study and look at short-term parameters to see if we can get a better indication of where we need to be at to get the best chance of an efficacious outcome.
Just to round that out, why calcium AKG rather than a more available arginine AKG?
Well, first of all, I'm not really happy with adding an amino acid to the mix. I think that depending on the individual, that may or may not have good outcomes. The calcium is actually quite low in the human form, and so we wanted to stick with a more simplified intervention so that we have a better chance of understanding mechanism. It's an interesting question of whether something like arginine AKG would have a bigger impact, and we haven't looked at that. I would also say that we're using a sustained release version, and I think that's important to get the molecules through the stomach and into the gut, and so you get better bioavailability.
Thank you. Nima Subramanian is asking, interested to hear what role nutrition and specific nutrients play in the panelists' perspectives, particularly current controversies around glycemic load, saturated fat, and salt intake in longevity.
Maybe Luigi, you want to take a shot at that first?
I think that, the role of nutrition and aging is perhaps, the biggest question that we have in the field, because I always say that during our life, we eat 70 tons of food. 70 tons is a mountain that is 50 meters tall And it's impossible that this amount of food will not have an effect on our health. The problem is that many of the studies of nutrition in humans are done with tools that are not working. They are biased, they're too noisy. And so I think that's where we need to make a strong improvement before we can, truly find the effect on the nutrition on aging in human health. I think that many of the animal studies are incredibly promising that show that both calorie restriction but also change in the quality of nutrition have an important effect in humans. We are still limited to the positive effect of Mediterranean diet. I think that we need to do a lot better to have a translational aspect of this.
And I would just add to that, that I think that we tend to study lifestyle interventions in absentia, as if they are the only change that matters. And, diet and exercise are going to go hand in hand. And so I think we need to better understand optimal nutrition for people that are sedentary versus people that are very active in terms of exercise and lifestyle. And there haven't been enough of those kinds of studies either. So I think there's a lot to be learned yet.
And can I just add, I think in the nutrition area, this is where genetics is going to be hugely important. And we really have very little understanding of the interaction of genetics with different dietary interventions, a little bit in animal models, but very little in humans. And to some extent, this is my personal view on this. I feel like the dietary interventions are in many ways much dirtier than something like rapamycin, where we know the specific target. And what I mean by that is they hit a lot of things in the biological network, which might mean that they're more susceptible to genetic and environmental interactions than something like a very specific molecule that hits one biochemical target. So I think we don't know at this point, but if I had to guess, that would be my guess, is that drugs in some ways are going to be more broadly applicable across many different genotypes and environments than dietary interventions.
Thank you very much. I'm sorry we're out of time for this, but this is a fabulous panel. Luigi and all the panelists, thank you so much.